to start off our unit on circles here, we just got a kind of a basic question, just going over some circle properties. Just using some of the terminology that's listed in this lesson, we're just gonna kind of list off a couple things. So I'm gonna list off 3 chords. Now we know that chords are going to be any sort of like line segment that connects 2 points along a circumference. So the chords in this case, 3 of them would be AC, that's from A going to C. You can see both of these points are on the circumference and there's a line connecting them. So that's called a chord. AD is also a chord. We have A connecting to D, both on the circumference, line segment connecting them. So that's a chord. And then finally, we're also going to have DB. We have D and we have B. They're on the circumference. There's a line segment connecting them. Kind of a good way to think of it is just as long as your points, your ending points, beginning and end points are on the circumference of the circle, so that's going around it, and there's a line connecting them, it's a chord. These things here, A to O, O to B, those are not going to be chords because they're passing through the circle first. We can go ahead and keep on going here, and we're going to get a tangent line. So a tangent line to the circle here is a line that touches the circle in one and exactly one place. So the line here is going to be FE. That's our line that's going tangent to the circle, and it touches the circle just at this B point. And B is kind of like a special name for B. Since this is the point of contact with the circle in exactly one point, we call this the point of tangency as well. Point of tangency. So a couple important points, but B is just going to be our tangent line. I'll just kind of write some of these down. Tangent line. Before these were all chords. And we keep it going here. Let's go ahead and let's get a central angle. Central angles, we don't want them to be over 180 degrees. We're looking for things that are less than 180 degrees. So I'm just going to kind of trace out a central angle here. We go from A, I'll do this in red, we go from A, we go to O and then B, and that's going to map out this angle right here. So we call this angle AOB. You could say BOA, that would be fine too. But really we're just mapping out this angle in the middle. O is going to be the vertex of that angle. So angle AOB equals our central angle. And again, we're looking for things that are under 180 degrees. This thing over here, the other side of it, that would not be our central angle. We're only looking for things that are under 180 degrees. So we'd pick like the inside one over here, or the one that's less. We can go ahead and we can get some inscribed angles. So inscribed angles, we're really just looking around the circumference, and we're going to try to see where the angles are that lead to 2 points that are on our circumference. So the vertex needs to be on the circumference, and then the 2 points also need to be on their circumference as well. So there's a couple of them here. I'll try to map out the first one here. We have starting from A, going to D, and then going to B. We have this one over here. D is on our circumference. A and B are also on the circumference, and they're actually going to map out an inscribed angle. So angle, and I'm going to say ADB is going to be a inscribed angle. We also want to look at if there are any other things here that have a vertex on the circumference and then 2 other points on the circumference. And there is only one other one. That's going to be our C to A to D. That's also going to be an inscribed angle. A is on the vertex here, is on the circumference, and the 2 ending points are also going to be on the circumference. So we would also put down angle C, A, and D. And both of these will be inscribed angles. All right. So we got central, we got inscribed. We can go ahead and we can just list off a couple arcs as well. Arcs are just going to be any 2 points on the circumference that are connected to each other. There's a lot. So let's go ahead and let's do AB. That would be the first one. A and B are both on the circumference, and they can make up an arc. So I'll say A, B, and for arcs, we just have to put like a little arc sign over it. So that's pretty easy. I think I'm going to stop marking it up because I'm going to kind of make this a little jumbled up. But D to B, that's an arc as well. So we can go D to B. I'm just going to put BD here. C and D, we can say that those are arcs as well. And we can kind of complete it off by saying C and A. Now, if you wanted to, you can always keep on going with arcs. You can go like CA. We already have AB, that's fine. You can go CD, CB, that would be fine, DA, all that kind of stuff. You could basically just connect any 2 points that are on their circumference, and you can make them an arc. So all of these here, I'll put a little note, these are going to be arcs as well. There is actually no special name for E and F. There isn't any name for it. They're just making up this line, this tangent line, E and F. So there isn't really anything special to do with those ones. They're just a part of this. Not too much else. I'll just kind of maybe extend it just a little bit here. We know that AO, this thing over here, is going to call it a radius. Ooh, that doesn't look too good on white, so I think I'll do it like this. This is a radius or a radii, we could say, for AO and also OB. Those are radiuses of the circle. And it doesn't look like there's any diameter in this diagram either. A diameter would have to go from edge or circumference to circumference, like so basically A, and then on the opposite side of it would be another point, and I would have to go through the center. I like to think of diameters as like two radiuses stacked, one after another. But that would really just be taking a look at some basic circle terms and going ahead and mapping out what our circle terms are for this diagram.